Question 4. A car accelerates from 10 meters per second at a rate of 5 meters per second squared for 3 seconds. So here's our interval. Its duration is 3 seconds long. We know that it accelerates from refers to initial 10 meters per second. That's a velocity. So this is initial velocity. So at the beginning, its velocity is 10 meters per second. It accelerates at a rate of 5 meters per second squared. Meters per second squared is the unit of acceleration. So we know the acceleration is 5 meters per second squared. What are we asked? A, what is the velocity at the end of these 3 seconds? So in other words, V final. So we are asked to find V final for the interval in A. And B, how far does it travel? How far means delta x, displacement. We need to find that out. So let's first answer A. First step is we need to decide what equation to use. It has to have the unknown variable V final in it. Otherwise, how will we solve for V final if it's not there? So we cannot use this equation nor that equation. Next thing, it cannot have delta x in because we don't know delta x. There can only be one unknown, and that one unknown must be the one that we're trying to answer, in this case V final. So this one won't help us, neither will that. So we can use either of these, which actually are the same equation. Just rearrange either of them and you get the other. V final is equal to V initial plus A delta t. We're trying to find V final. V initial is 10 meters per second. Acceleration is 5 meters per second squared. And delta t is 3 seconds. 10 plus 5 times 3 is 15. Gives us 25. We're speaking about velocity here. Velocity's unit is meters per second. And this is a vector quantity, so we should really give a direction as well. The direction is positive. We haven't been told which direction was taken as positive, right or left or north or east or whatever, so we can just say in the direction of motion. So we can now put that value in our information diagram over there. V final is 25 meters per second. Now we have to solve for delta x in B. So our equation has to have the unknown variable delta x in it. So that equation doesn't help us, and nor does that one. We have all the other variables, so we can use any of these equations. It would be a good idea for you to try using each of them and see that you get the same answer no matter which equation you use. We're going to use the top one. Delta x is equal to V initial plus V final over 2 multiplied by delta t. Now you should notice that is the same equation as this one, just rearranged. Why? Rearranged to make delta x the subject of the equation. Here you get delta x is equal to average velocity multiplied by period of time. During uniform acceleration, average velocity can be got by adding the initial with the final and dividing by 2, and then multiply that by delta t. So the first part of the equation is just finding out the average velocity for the interval. The average velocity is 10 plus 25, the initial and final velocities, divide by 2. Then we multiply that by the time duration, 3 seconds. 10 plus 25 divided by 2 is 35 divided by 2. We multiply that by 3, and our answer is 52,5. This is a displacement. How far does it travel? And so our unit is meters. It doesn't actually say get the displacement, so we could interpret that as just the magnitude, so maybe we don't need to give a direction, but displacement is a vector, so if we'd been asked for displacement, we'd have to give a direction as well.
And before we go, have you already liked? Have you subscribed? Have you left me a comment? And please go and visit my website. You'll find a lot of resources there, and they're categorized in a way that will make it very easy for you to find what you need. Until we meet again, learn science!